Hello guys. In this video, I would like to cover integration by partial fractions. Okay. So number one, we need to integrate x cubed plus 2 and all over x minus 2 into x minus 1. Okay. We on partial fractions. Basically on partial fractions, we are given a simplified fraction, but now we're trying to reverse to see it is original improper fraction. Okay, before it was a simplified fraction, there was a improper fraction which was not simplified. Okay, so even here we are trying to do that, and so that we'll be able to integrate by partial fraction, so that we just be able to integrate after we have find the original fraction. So after we have found the original formula, we will have something like this. It will be x cubed plus 2 all over x minus 2 into x minus 1 with respect to x, and is will be equal to, so we can see here this is a linear. X minus 2 is a linear, and x minus 1 is also a linear. So if we approach a linear, we need to have a over x minus 2 and plus a b over x minus 1, and we integrate with respect to ox. Okay, so now we need to find a and b. So in order for us to find a and b, we need to rewrite this and solve for a and b. Equal to, it will be a over x minus 2 and plus b over x minus 1. So to find for a and b, we need to cross multiply with the denominator. Always you need to cross multiply with the denominator. It's not something like you need to think about it, you just need to know it. Okay, so it is x minus 1. So when we multiply on the left hand side, these two brackets will cancel with these two brackets, and we'll be left with x cubed plus 2 equal to, and these two brackets times divided by this bracket, we can put bracket if you like. It will be left with x minus 1, and x minus 1 times a. So if this one confuses you, you are able to say a times x minus 1 and b times x minus 2. So it on this side we'll be having a b into x minus 2. Okay, now we need to find a and b here. If we can see here, if we can just make this whole bracket to be 0, and we can be able to find b. So how are we going to make this whole bracket to be 0? We can say let's x to be 1. So if x is 1, and therefore on this side 1 cube will be 3, but maybe let me just substitute a plus 2 equal to, and this one will become 0, and we will having a b into 1 minus 2, and 1 cube plus 2 is 3, and equal to minus b, and therefore our b will equal to negative 3. Okay, now we can also see that if we can make x to be 2, and then we can find our a, since this one will disappear. So let's do it. We say let's x to be 2, and therefore we have 2 cube plus 2 and equal to a 2 minus 1, and this other brackets will disappear, of course, and therefore on this side we'll have 2 cubed, which is 8, and plus 2, which is 10. So and our a is equal to 10. Okay, so now we go back and say the integral of x cubed plus 2 over x minus 2 into x minus 1 with respect to x. What we are writing now is this one, okay, so that we will be able to substitute. But now we already know our a, so here instead of writing a, we will write a 10 over x minus 2, and here instead of b we write negative 3, so we will have a negative 3 over x minus 1, and therefore we need to integrate with respect to x and integrate with respect to x. Okay, now we rewrite x cubed, integral of x cubed plus 2 all over x minus 2 into x minus 1 with respect to x equal to, then we take out the constant so that we'll be able to integrate. So we have 1 over x minus 2 with respect to x, and minus 3, we take out the 3 outside, so we'll be left with 1 over x minus 1, sorry, with respect to x. And therefore our answer here will be x cubed plus 2 all over x minus 2 into x minus 1 with respect to x will be equal to 10 ln into x minus 2 and minus 3 and ln into x minus 1, and we have integrated, we say plus the constant. Okay, and therefore we have the integral of x cubed plus 2 all over x minus 2 into x minus 1 will equal to the final answer of a ln, and we can already see there is a negative, but now we cannot apply the logs while we have the coefficient of 10 and then a coefficient of 3, and therefore we'll put 10 in this power, and therefore we'll have x minus 2 raised to 10. So okay, and we also have x minus 1 all raised to 3, and then we are left with this negative, and then we apply this log and we say plus c. So this one is our final answer. Okay, number 2, we want to integrate a 2x cubed plus 3x squared plus 4 all over x minus 1 into x squared plus 2 to x squared plus 2, and with respect to x. Obvious, this is a partial fractions, so by observing our denominator, and that is what you need to do first. So you need to observe your denominator. If you have a linear, if you have irreducible, if you have a repeatable factor. So in this case we have a linear and we have a irreducible. Last time we had only linear, so now it is the combination of a linear and irreducible. Okay, so we say a 2x cubed plus 3x squared plus 4 all over x minus 1 into x squared plus 2, and will be equal to a, since this one is a linear, so it will be a over x minus 1 and plus, now this one is irreducible, so if it is irreducible you need to have a bx plus c all over all over x squared plus 2. Now, if this bracket was on this side, you will be having ax plus b. I hope you see what I'm trying to say. And now you get rid of the fraction, and so that you solve for ABC. Now, what you times here in both left and right, you times with the denominator, exactly the denominator. So it will be x minus 1 into x squared plus 2. Okay, so this will cancel with this one, so we will be left with 2x a cube plus 3x squared plus 4 equal to, when we times this one with this one, and this one will cancel with this one, and we'll be left with x squared plus 2. Or simply just cross multiply here, then we'll be having a times x squared plus 2, a times x squared plus 2, and on this side plus, it will be bx plus c into x minus 1. Okay, now we need to find for a. So in order for us to find a here, we can see that if we can make let x to be 1, and this whole bracket would become 0. So if this whole bracket would become 0, and then we will be left with a to solve. So let's substitute. So we have 2 1 cube plus 3 into 1 squared plus 4 equal to a into 1 squared plus 2, and this bracket will become 0, and therefore we will have 2 plus 3, which is a 5, and plus 4, which is 9, and therefore we have 9 equal to, and this one will be 3a, and therefore our a will become 3, since a 9 divided by 3 is 3. Okay, now that we have our a to be 3, we now want to find out how can we find either a b or c. But now, looking at b, if we can just make x to be 0, and b will disappear, and we already have our a, and x is 0, and therefore we'll be left with c to solve. So let's do that one. So let's x to be 0, and therefore this whole thing will disappear, and we'll be left with 4 equal to, and our a is 3, and we'll be left with a 2 here, and plus on this side we'll be left with c, since b will disappear as well, and here we'll be left with a negative 1, and therefore we will have a c equal to, if this one is the product, therefore we'll have a negative c, and we transpose c to be on the left hand side, and we transpose 4 to be on this side, and therefore we'll have a 6 minus 4. So we have 6 minus 4, which is 2. So 6 minus 4 is 2. So this is our answer. Now we have our a, we have our c, but now we don't have our b. We can just take any number. We can take 2, we can take 3, but now we avoid the big numbers so that we can not get bigger numbers. If you can see here, if you put a 2, you get 8, but if you put a 3, you get a bigger number. So we avoid bigger numbers. So we can say let's x to be 2. So 2 is fine. So we say 2 into 2 a cube plus 3 into 2 a squared plus 4, and equal to, our a is to be is 3 into a 2 squared plus a 2, and plus a b attached to 2, and there are brackets here, and plus c, but now our c is 2 as well. So sorry, is 2, and we have a 2 minus 1. Okay, and then if we can put this on our calculator, we will have 26 equal to, and if we can just solve everything here, we'll be left with 2b plus 2, and we have 18 here, and this is 18, and plus 2b, and plus 2, and therefore we say 18 plus 2, which is 20, and 26 minus 20 will be left with 6 equal to 2b, and therefore our b is found to be 3. Okay, so it is positive 3. Now we can go back here and substitute our values. So we will have something like the integral of 2x cubed plus 3x squared plus 4 is equal to x minus 1 into x squared plus 2 with respect to x, and is equal to our a is found to be 3 over x minus 1 plus our b is found to be 3 as well. So this will be a 3x, and our c is found to be 2, and this is all over x squared plus plus 2, and we are integrating with respect to x. Okay, and we have let me just put equals so that we minimize our video. So we have the integral of 3. We take out the 3 as a constant, so we'll be left with 1 over x minus 1 with respect to x, and therefore we can now integrate here. But here we can just simplify this fraction. So if we can simplify this one, it will be a plus the integral of 3x all over x squared plus 2 with respect to x, and we have a plus 2 over x squared plus 2, and we integrate with respect to x. Okay, now we can integrate. Here we need to use the method the appropriate substitution, and also here we need to use the appropriate substitution. But here we can maybe avoid the appropriate substitution, since we can if we can find the derivative of x squared plus 2, it will be a 2x, and we can have a 2x here, and we take out this one and we put 2, and we just compensate. So here it is applying the normal integration. Here we compensate, here we integrate using an appropriate substitution. Okay, maybe let's do it. So we'll have equal to, and maybe let's put it down. So we'll have 3 over 1 over x minus 1 with respect to x, and we say plus, we compensate here, we take out the 3 as a constant, but now we want 2x, and we will take out the 2, which is 2, integrate over x squared plus 2. So if you don't understand what I'm trying to do here, what is the compensating, if we derive here, we will find that our derivative of x squared plus 2 is 2x. So we don't have a 2x, but we have x, since after taking out the constant of 3. So now we put that 2 that we're supposed to have, and we take it out. Do you understand? So if we this one will just a 1 will cancel. Understand? So there's nothing wrong, or there's nothing we have changed on this problem. We just what we have done is a compensation. So here we let maybe let me write it here. We let u to be x squared plus 2. This is integration by appropriate substitution, and therefore we look for dx. So in order for us to get dx, we need to derive this one with respect to dx. So du over dx will equal to 2x. It will equal to 2x and a plus 0, and therefore we find dx, and our dx will equal to 1 over 2x and du, and therefore we substitute here. If we substitute, we will have something like this. We say plus, of course, 2 is a constant, but let me just substitute everything. So we have a 2 over u, and we have our dx to be 1 over 2x and du. So this one will cancel with this one, but now there is 1 over x. Now since we are integrating with respect to a du, 1 over x will be a constant here. Since we integrate with respect to u, everything that has no x or has no u, it's considered to be a constant here. Okay, so we have let me just put it down here. It's 1 over x minus 1 with respect to dx plus 3 over 2 and 2x over x squared plus 2 and dx, and we have a plus. We take this one out, and we have 1 over x, and we integrate 1 over u with respect to u. And when we integrate here, we will be left with 3 ln into x minus 1 and plus 3 over 2 ln into x squared plus 2, and we have plus 1 over x and ln u. But now ln u is x squared plus 2, and we say plus 2, and then we can continue simplify, but this is our answer. It's plus c.